Hello again, and welcome to another review session for your final exam in Calculus 3208. We're looking at today the derivatives of expressions that involve trig functions. So last time, in our last session, what we looked at was actually how do we differentiate the primary trig ratios. So in this section, what we're going to do is we're going to look at ways for us to differentiate a whole slew of different functions that can involve combinations of those trig functions with other things. So we're going to look at using the derivative formulas that we have for the 6 trig ratios in combination with our old friends, the product, quotient, and chain rules, all in the context of differentiating trig functions, which we all know and love. Okay, let's get right down to some common pitfalls. So these are notational issues, and one thing about trigonometry, sometimes the notation is a little bit gross. So things we've got to be careful about as we go through this. The first one is, remember that if I have sine of x squared like this, that's the same thing as sine squared of x. So be careful, because that's not the same as sine of x squared written this way or sine of x squared written this way. So basically, we got to be careful to notice that I'd have to have brackets around the whole thing to be sine squared, or these two are equal to each other, but they are not in fact equal to them. One and the other are not the same. So let's see now the second thing. Remember that cosecant is the reciprocal of sine, and since it's a reciprocal, we could write it as an exponent of -1, but we're not allowed to put that exponent in here like we could with the 2. We can't do that. They're not equal, because that's actually the inverse sign or the arc sign. It's one of my biggest pet peeves in mathematical notation, is that this is really inconsistent. So I prefer to use the arc sign notation instead of the sign with the -1 there to avoid the confusion, but because your textbook uses this one most predominantly, and as does the sample CPT that we've seen, I think we'll stick with it for now. So we'll get into this stuff, the inverse trig functions, later, but for now we'll see lots of these guys coming up. And the last one is, be careful about arguments. Sine x cos x is 2 trig functions multiplied, but sine cosine x is actually implied that we have a composite function with the cosine inside the sine. So all of those things are sort of details that you have to be careful about when you're going to go and actually differentiate these things, so you don't get mixed up about which rules you're supposed to be using, etc. So let's do some examples. Okay, this is complicated. So we have to differentiate and simplify this first one. So for this first one, I've got a constant multiple, which I know I'm just going to carry with me, and then I've got a whole bunch of nested functions. So in order, I've got a cosine on the furthest outside. Then the next thing is going to be actually squared, because that's all squared what's inside there. Then it'll be the sine, and then I'll have to worry about the 3x. So let's do this. We're going to peel off one layer at a time like an onion, or like an ogre, as Shrek would say. So we've got f prime of x is equal to, we've got 2 first, and then I'm going to differentiate the cosine. So that's going to be negative sine, so I'll put the negative out in front. And I leave the stuff that's inside alone for now until I get to deal with it on its own. Then the next layer I have to differentiate and multiply by will be that square, according to the chain rule. So then I've got 2 times the sine of stuff to the power of 1, which I won't need to write. So it's 2 outside of sine of 3x. Then I need to differentiate this sine, so that's going to be a cosine of 3x. And then last but not least, the argument of the furthest most inside function is 3x, so its derivative will just be 3. So I've got to see if there's anything I can collect together there. There's not going to be a whole lot, but I can at least put my constant multiples together. 2 times 2 times 3 is -12, because we had a negative out in front. And then I can't combine anything else there, and we'll talk about why for just a quick second. I've got the sine of sine squared of 3x, and that's multiplied by sine 3x and cosine 3x. All right, so it's tempting to try and get this sine squared 3x with this sine x together, or sine 3x together, but you can't do that because these guys are independent of what's inside this one over here. They're just multiplied through, so I cannot combine anything there. That's as simple as it gets. As ugly as it is, that's as simple as it gets. Okay, let's try another one. So it looks like we're going to have a quotient rule here. Now I could try to rewrite these in terms of sine and cosine, but let's attack it as it is. So a quotient rule, I'm going to start with f prime of x, and it's going to be, so quotient rule, remember, is derivative of numerator times denominator minus derivative of denominator times numerator all over denominator squared. Okay, so let's start this one off. Now, So the derivative of cosecant squared is going to be 2 times cosecant x multiplied by the derivative of cosecant, which is negative cosecant, cotan, like so. And then I have to multiply that derivative by the denominator, which was secant x. And then I have to subtract the derivative of the denominator. So the derivative of secant is secant x tan x. And then I have to multiply that by the numerator, which was cosecant squared x. All right. So that's all then one numerator, and it's all divided by our denominator squared, so secant squared of x. Okay, let's try and simplify anything we can here. Before I get into too much, I'm going to notice that I've got a secant here and a secant there, and I've got a secant squared down here. So if I just reduce that to one secant, I can get rid of both of those right off the bat, and that'll make my life a little bit easier. So we'll call this negative 2 cosecant squared times cotan will be my first term in the numerator. And then my second term in the numerator is going to be negative cosecant squared x times tan x. Doesn't matter what order we write them in because they're just multiplied, of course. And that's all still divided by secant of x. Now, I do like to remove common factors when I can in the process of simplifying. So I see that I have a common factor here of negative cosecant squared. So let's pop that out. We'll have negative cosecant squared x times 2 cotan x, and then it'll be plus tan x all over secant x. Now you could try to do something with this and take one of these cosecants, put it over the secant and make it a cotan, and then you wouldn't have any fractions, but it's not really a heck of a lot simpler. So I think I'd leave it like that, and I'd say that that's simplified enough. All the obvious stuff is done anyway. Okay, let's do some test type questions. And I know that a big part of what you'll have to do on your calculus placement test will have a lot to do with differentiating functions like these and then choosing from multiple options as to which one is correct. So let's look at this. We have to first differentiate y equals the square root of tan of x squared. Okay, so lots of layers here. Outside most is going to be that square root, then the tan, then the x squared. So let's get at it. dy over dx. The square root is going to tell me I have 1/2 of the stuff that's inside, tan of x squared, to the power of negative 1/2. Then I have to differentiate the tan, and the derivative of tangent is secant squared of what's inside that, which is x squared. And then I need to differentiate the x squared, which is just a 2x. And then we get to simplifying to try to match one of these things. So 1/2 and 2, they can cancel each other out because 1/2 of 2 is just 1. And then I'm going to try to collect stuff that would be numerator and stuff that would be denominator for a fraction based on positive and negative exponents. So positive exponents, I have an x times secant squared of x squared. And then my denominator is going to be tan of x squared to the power of 1/2, or if we want, the square root of tan of x squared. And which one matches that best? Scanning, scanning. Oh, here it is. That's exactly what we have. So we've got x secant squared, x squared, all over the square root of tan of x squared. Let's try another. Differentiate cosine of a polynomial. Well, that looks fairly straightforward, doesn't it? So let's get at that one. So y prime, we'll call this one, is going to be the derivative of cosine is negative sine of the guts, x squared minus 3x. And then I have to multiply by the derivative of the guts, which in this case is polynomial, so it's just 2x minus 3. Okay, so that's going to give us, boy, there's not much I can do to simplify. I suppose I could write this out in the front if I wanted, but I don't see any reason to do that. Let's check our answers and see if anything matches up. And one of them does right here. C is exactly what we were after, so there was no simplification required there at all. This one's pretty close, but they have the wrong sign. This one and this one, wrong sign for one of them, and one of them forgot to multiply by the derivative of the innards. And oh, look at this over here. They had the whole thing listed in the argument of the sign, so that's not right either. So C is our only option. Okay, we got one more to do? All right, let's do it. Woof, this looks fun. So we've got f of x equals cosine squared of 3x times sine cubed of 2x. A little switcheroo on those numbers. Let's go for, I'm going to start way over here on the left because I'm betting this is going to be one heck of a long derivative. So let's get at it. So this is going to be in the big picture here, I've got a product rule. And each of the components of my product rule is going to have 3 layers to differentiate it as a chain rule for itself. So the first one, if I differentiate cosine squared 3x, that's 2 times the cosine of 3x multiplied by negative sine of 3x multiplied by 3, because the derivative of 3x is 3. Then, because this is product rule, I take the derivative of that factor and I multiply by the second one, which is sine cubed of 2x. Then to all of that, what I have to do is I have to add the derivative of the second part multiplied by the first part. So that's going to be 3 sine squared of 2x multiplied by cosine of 2x for the next layer in. And then the next layer in there will be a 2. And then I multiply all of that, which is my derivative, by the first function, which was cosine squared of 3x. So I've got cosine squared 3x there. Gross. Okay, so what I have to do now is try to simplify. So anything that I can get together and combine. Well, let's start with any numerical multiple. So constant multiples. I have a 2 and a 3 there. That's going to make a 6. And then I have a negative here, so I might as well put a negative 6 out front and make it nicer. And then just write down all the different factors that we have. Cosine 3x, sine 3x, and sine cubed of 2x. Okay, so that's nice. And then we're going to have 3 2's are 6 over here, and I've got sine squared of 2x and cosine 2x and cosine cubed of 3x. Okay. Now there's some common things between those two, so I think I want to remove a common factor here. So let's go after a common factor. The first thing I see there that's going to be a common factor is 6. Let's pop the 6 out of there. Then I'm looking for other things we have in common. So this first fraction has a cosine of 3x, and this one has a cosine cubed of 3x. So I can get at least a cosine 3x out of those. And then the first one has a sine 3x, but there's no sine 3x's over here, so that's no good to me. Then I've got a sine cubed of 2x here, and in this one I have a sine squared of 2x, so I can take out a sine squared of 2x as a common factor. And there's no cosine 2x in my first one. So that's pretty much everything I'm going to get out of that. So let's see what's left over inside now. So if I take out a cosine 3x times sine squared 2x, so for my first term here, that's gone. The 6 is gone. It's still negative. Sine 3x is still going to be there. And this sine cubed of 2x is just going to be sine of 2x. And so I'm going to write that one second because it's negative, and I like to put my positive one first. From my second group, the 6 is going to be gone. All of the sine squared 2x will be gone. And my cosine cubed of 3x is now going to become cosine squared of 3x. So I've just got cosine squared of 3x left in that one. Okay? But that should have been just a cosine squared in the first place, shouldn't it, from up here? Excuse me. So that's just going to be cosine 3x. Sorry about that. Caught it, though. That's all right. So what that means is now we're going to have in the end here, just from the second one, which was positive, cosine 2x times cosine 3x, cosine 2x, cosine 3x. And then from the first one, I'm going to have negative sine 2x and sine 3x. Now hang on. If I look carefully at what's inside those square brackets there, I have cosine A, cosine B minus sine A, sine B. And that's a regular old identity. So I can simplify that. So this becomes 6 cosine 3x. I don't usually go hunting too hard for identities with these things, but that one kind of jumped off the page at me. Sine squared 2x. And then what we're going to have here is actually cosine of A plus B. So that's just going to be cosine of 2x and 3x, which is 5x. And so there's as simplified as I can make that without getting into way more detail and hoping a whole lot. So that's a good one for that. Okay, let's take a look now at the your turn question. So you've got the square root of tan 2x, and then you got cosecant squared x, cosine x. I'll jump to the solution. So if you want to pause, go ahead. And there's your solution for that. in all of its gory details and simplified guts. And let's highlight some of the key features. So differentiating trig expressions requires using trig formulas for the derivatives of the 6 basic ratios, so the formulas that we had. Careful use of product, quotient, and chain rules, and watch out for those notational issues. So those 3 things we highlighted earlier, make sure you understand why those things are true and they're not all equal to each other. So be careful with that. It can cause you some headaches. Hopefully that was helpful, and good luck studying. And if you have any questions, put them up.